Okay, all right, for this video, we're going to finish up 9.1, the second day on sequences and series. If you look at the outline of the notes that you have, there's 3 sections. On this video, we're only going to cover the first 2 sections. They're pretty straightforward, pretty basic, so you should have a good understanding of them. The last section, section 3, is where we're given the sequence and we want to come up with the formula for it. That's probably the most difficult part and might be the most difficult part in all of Chapter 9. We're going to do that in class tomorrow. All right, so let's do this. If it says nth partial sum, okay, what this means is you're going to be given something where it's in sigma notation. So if I look at here, this is sigma notation right there. And you can see for 1 and 2, it has it that it goes to infinity. So that means you take all the numbers in the sequence, and if you add them all together, it should approach a certain number. But then it kind of counteracts it. It says find the fourth partial sum. Well, partial means that you're not going to add everything. You're only going to add a part of everything to infinity. So they kind of counteract each other. If they ever said find the fourth partial sum, this is what it means. Just add the first 4 terms. Sometimes in math, they just make it a little bit more difficult by the wording of it. This is all it means. So this is what you literally could do. You could take this infinity. I could cross it out and just change it to 4. That means the fourth partial sum. Same thing for number 2. Get rid of infinity, change it to 4. Okay, it means the same thing. All right, now I'm just going to do number 2. Number 1 gets a little bit messy with fractions. I'll probably do that in class tomorrow. Probably start out class with that. I'm going to do number 2, and all I have to do with number 2 is just add the first 4 terms. Plug in I equals 1, I equals 2, I equals 3, I equals 4. Get the values for them, and then add them together. So I'm going to put a little bit of the work right here because it always gets a little messy when I do this on the video. So if I plug in I equals 1 for number 2, I'm going to have 1 squared plus 1. Well, 1 squared plus 1 is just going to give me 2. If I plug in I equals 2, we're going to have 2 squared plus 1. So that's 4 plus 1, which is 5. If I plug in I equals 3, so we're going to have 3 squared plus 1. 3 squared is what? 9. 9 plus 1 is 10. And then the 4th term, I plug in I equals 4, so it's 4 squared plus 1. So it's 16 plus 1, which is 17. And this is all I do, right? As soon as I see that sigma, I know I'm adding. So it's really a series that we're adding. And this is all we're doing. 2 plus 5 plus 10 plus 17. Add those up. Let's see here. I get 7. I get 17 plus 17. We get 34. So that's our answer. So our fourth partial sum for number 2 is 34. Okay, let's move on. Let's do the last part of this video. Okay, again, when you look at the terminology, it actually looks a lot more difficult. If you just read that, sequences defined recursively, that looks a lot more complicated than what it really is. We're basically given the formula for the sequence, but it's just written a little bit differently than what we saw for the first day. Now, recursively means that you're kind of looking in the past. Now, it gives me the first term. And I want to find the first 5 terms, so I want to find at least the next 4 terms in the sequence. This is the formula, but it's actually defined recursively. So what it means is what's solved for is what the next term in the sequence is. So what I'm going to do is I'm going to let for this formula, I'm just going to plug in k equals 1. Now when I do that, I don't have a sub 1, but I'm actually taking this k equals 1 and plugging it into here. So 1 plus 1, this gives me a sub 2. So this is what's different. And then this is what I mean. I go into the past. So when I plug in k equals 1, I plug it into here. So it's just a sub 1 plus 2. And then it's pretty easy. I know this is a sub 1 here. This is the 6. So I just plug it in. It's just 6 plus 2. So a sub 2 is 8. That's it. This is just a more fancy way of saying, all right, to get the next term in the sequence, keep adding 2 to the previous term. So if I wanted to find a sub 3, well, in this formula, I let k equal 2. Right? If I let k equal 2, then I have a sub 3 equals, right? I'm plugging k equals 2, so 2 plus 1 is this a sub 3. I'm going to have a sub 2 plus 2. And I know a sub 2 I figured out was this. It's the 8. So it's just 8 plus 2, which is 10. So all I do is I keep adding 2 to it. So I'm not going to do the whole process of taking k equals 3, plug it in, take k equals 4, plug it in, k equals 5. Let's just follow the pattern, right? I have 6, then I have 8, then I have 10. This is an arithmetic sequence. I keep going up by 2. So the fourth term, I just add 2 to this 10. All right, so the fourth term here is 12. And then the fifth term, I just add 2 to it. I get 14. So there it is, 6, 8, 10, 12, 14. Those are all 5 terms there. Okay, if we look at number 4, this is going to be a different type of sequence. This is actually going to be a geometric one. So we'll do the same thing. I have the first term. So to find the second term, I want to find a sub 2. Well, in order to do that, I have to plug in k equals 1 here. So if I plug in k equals 1, it's going to be, right, I'm plugging k equals 1 to this, so it's going to be a sub 2 equals, I plug this k equals 1 into this, so it's going to be negative 2 times a sub 1. So it's negative 2 times a sub 1. Well, I know a sub 1 is this, it's 14, so just plug it in. So negative 2 times 14, the second term then is negative 28. So this is just more of a fancier way of saying, all right, to get the next term in the sequence, just multiply the previous by negative 2. So I'm just going to go on. Let's just get the other numbers. I'm going to take this negative 28. If I multiply that by negative 2, I get positive 56. For the fourth term, I take the 56, multiply it by negative 2, and what do we get for this? Negative 112. And then to get the fifth term, I just take the previous term, this negative 112, multiply it by negative 2. Negatives cancel out, and we get positive 224. All right, so really all these problems that we did, they look a lot more complicated, but really when you know what they mean and you know how to get started, they're very, very, very simple. Okay, so we'll start out number 1. We'll do that in class tomorrow with the partial sum. And then this is what we're really going to focus on. These are a lot more difficult than really anything that we've done yet in Chapter 9.